Hey everyone, welcome back to Cracking the GRE Math Subject Test. We're on the number theory and abstract algebra chapter, and this is our fourth question. This question is a little bit tricky. It tells us there's three numbers, x, y, and z, positive integers, and that the expression 4x minus 5y plus 2z is divisible by 13. And then it asks us which of the following expressions also has to be divisible by 13, and we're given 5 choices. Well, one way to do this problem is to sort of trial and error, try different numbers and see what works. For example, if we try x equals 4 and then y equals 1 and z equals 1, we get 16 minus 5 plus 2, which is equal to 13. So we know that 4, 1, and 1 satisfy this statement. And then we can check which of these other statements also is satisfied by these three numbers. So for A, we get 4 plus 13 minus 1, and that gives us 16. That's no good. For B, we get 6 minus 10. 6 times 4 is 24, minus 10 times 1 is 10, minus 1, yeah, that's equal to 13. So we might be tempted to say, okay, B is the answer. But we have to be careful here because we've got y and z, they're both equal to 1. So this might, another expression might also work. So let's see, C is would be 4 minus 1 minus 2, and that's equal to 1. That's no good. And D is equal to negative 28 plus 12 plus 3, which would be negative 13. So that actually works because negative 13 is also divisible by 13. And E is negative 20 plus 3 times 1 is 3 minus 4. So that gives us negative 20 plus 3 is negative 17, minus 4 is negative 21. So that's no good. So we can eliminate A, C, and E, but we still have B and D as possible answers. And we would have to find another set of numbers, x, y, and z, that will, in order to check these two. Well, let's see. I know it says that x, y, and z are positive integers, but I think if we use negative integers, it won't really make a difference. So if we take x equals negative 1, y equals, let's see, negative 4 and negative 5 is negative 9. So y equals 1, and then z equals 2, or negative 2. We'll have negative 4 minus 5, that's negative 9, minus 4 is negative 13. So that's also divisible by 13, and then we can check. Does B work with these three numbers? Well, we'll have negative 6 minus 10 minus times minus negative 2, that's plus 2. So negative 6 and negative 10 is negative 16, plus 2 is negative 14. So B does not work in this case. Well, let's try D. D will give us negative 7 times negative 1 is positive 7, plus 12 times 1, that's 12, plus 3 times negative 2. Well, what's 3 times negative 2? That's negative 6. 7 and 12 is 19, minus 6 is 13, so that works. So our answer is D. Alright, well, this trial and error, it works, but it's not so reliable. Another way to do this is to use our knowledge of congruence relations. If we write the equation 4x minus 5y plus 2z is congruent to 0 mod 13, that's what it means for it to be divisible by 13. Remember that. It just means that when you divide by 13, the remainder is 0. Okay, so we can add and subtract multiples of 13 to this expression, to both sides of this expression, and then the right side will still stay 0, and then the left side we can try to arrive at one of these, at our answer D. So, for example, if you add the expression negative 39x is congruent to 0. Remember, 39 is a multiple of 13, so 39 times any integer is still a multiple of 13, so it's congruent to 0. Then you get negative 35x minus 5y plus 2z is congruent to 0, because you can just add congruence relations like that, mod 13. And then if you add 65y, remember 65 is 13 times 5, so that's also congruent to 0. Do a plus 65y, which is congruent to 0. Then you get negative 35x. 65 minus 5, that's positive 60. Y plus 2z is equal to 0 mod 13. And then if you add 13z, mod 13, then you get negative 35x plus 60y plus 15z is equal to 0 mod 13. And then if you divide the whole thing by 5, then you get negative 7x plus 12y plus 3z is equal to 0 mod 13, which means that this expression is a multiple of 13, and that proves that D is the answer, but it's pretty, I mean, this is a nice proof, but when you're doing the exam, it would be kind of hard to figure out that you have to add 65y and subtract 39x and add 13z. So the trial and error method might actually be easier in this case.